try to do some calc here. So, let's see if we can maybe get through this and give you guys time to get your homework done fast since you have 7,000 things going on. That would probably help. All right, we did the derivative of sine yesterday. What is the derivative of sine?
Cosine.
Cosine. Let's figure out the derivative of cosine the same way. So, we'd have to do the limit as h approaches 0, f of x plus h, so cosine of x plus h, minus f of x, so minus cosine of x, all over h. So our handy-dandy trig formula sheet that I gave you back at the beginning, what's cosine of a plus b?
Cosine.
Cosine a, cosine b, minus sine a, sine b. Okay, and then yesterday when we did this, we kind of got creative. And I reorganized things a little bit. So both of these terms have something in common. They both have a cosine x. So I'm going to put those two in a fraction. And I'll put the other ones in a fraction. So, in this first fraction, I have two terms. They both have a cosine x. So I could factor that out. And that leaves us with a cosine h minus 1 over h. Minus, and this one I'm just going to pull the sine x out and leave this as sine h over h. Alright, so then cosine h minus 1 over h. When h goes to 0, what does that go to? Yesterday. Limit theta approaches 0, cosine theta minus 1 over theta?
Oh, 0.
Goes to 0. Minus sine x. Limit as theta approaches 0 of sine h over h. That goes to. So we get 0 minus sine x or negative sine x. So the derivative of sine is cosine. The derivative of cosine is negative sine. So that's the second trig function. Any questions about that? And there is a slide a little bit later on that has all 6 trig functions together. So if you like to highlight in your notes, you could wait until we get to that slide to highlight them all if you want. So it's all in one spot. I mean, you can do it here too, but. If I want the derivative of tangent, it is secant. I am going to prove this one to you. This will probably be the last one that I actually work out and show you why it is what it is. So tangent is the same thing as sine divided by cosine, right? So if I ask you to do the derivative of this, to do the derivative of sine over cosine, we'd have to do the quotient rule. So quotient rule is low, d high. What is the derivative of sine? Cosine minus high, d low. What is the derivative of cosine? Over low squared. cosine times cosine, which is cosine squared x. Negative sine times negative sine is positive sine squared x over cosine squared x. What is cosine squared plus sine squared? 1. Most important trig identity. And 1 over cosine squared, so the reciprocal of cosine is secant. So the derivative of tangent is secant squared x, and that's how we get it. The others, we can do the same way, just doing quotient rule. So derivative of cotangent, you do cosine over sine, and do quotient rule. Secant, 1 over cosine, do quotient rule. Cosecant, 1 over sine, do quotient rule. So in a minute, I'm just going to give you those remaining derivatives, but you could, if you forgot any of them, as long as you know the derivatives of sine and cosine, you can get everything else from that just by doing a quotient rule. All right, let's practice some more of these. So if I want the derivative here, so what would I have to do? Quotient. So low, d high. What is the derivative of sine x? Minus high, d low. So derivative of 1 is 0, plus the derivative of cosine is negative sine over low squared. We want to clean this up as much as we can. What options do we have? Could we do? Distribute. So we get 1 times cosine x is cosine x. Cosine times cosine is cosine squared. Negative sine times negative sine is positive sine squared x. Recognize anything here?
Cosine squared x plus sine squared x.
Yeah, that's a 1. Anything else?
You could go ahead. Well, no, it's squared, but I mean, top and bottom.
Yeah, they're the same. 1 plus cosine is the same as cosine plus 1. So we could reduce that whole thing. The bottom, we have 1 of them. Or sorry, the top we have 1 of them. On the bottom we have 2, so we could cancel 1 of them. So that just leaves us with a 1 on top and a 1 plus cosine x on the bottom. We got our derivative.
Would you be able to turn that in like 1 plus secant x or?
No, because it's 2 terms on the bottom and you can't split them. But if it were flipped, it was 2 terms on top and 1 thing on the bottom, you could break it apart like that. Other questions? Let's keep going. We're a little bit ahead because I was able to start some of our lesson yesterday. So let's do a few more of these derivatives before we stop for today. All right, find dx dt. That's another way of saying find the derivative. This is x equals cosine cubed t. We are going to have to rewrite this. Cosine cubed, I could write it like this, but we still don't have a rule yet. We have a rule if it's just x to a power, but not if it's a function to a power. So what's another way I could write that?
Cosine t times cosine squared t.
but we can't do the derivative of cosine squared either, so let's just write it 3 times. So if I'm doing this derivative, we haven't done one like this before, but the product rule, we've always done it when it's just 2 things multiplied, but we can use it to extend if it's more than 2. Basically, you do 1 at a time, everything else stays the same. So if I looked at my first one, what is the derivative of cosine? Negative sine t. And the other 2 stay the same. Plus. Alright, working my way down the line, now we can do the derivative of the middle piece. Derivative of cosine is negative sine. So the first and last ones stay the same. Plus, I've done the derivative of the first 2, so this time those would stay the same. Derivative of the last one, which is negative sine. Is that okay? So, if we simplify this, I have negative sine t cosine squared t plus negative sine t cosine squared t plus negative sine t cosine squared t. All these are the same, so we can add the coefficients. Negative 1 plus negative 1 plus negative 1 is negative 3 sine t cosine squared t. So the product rule can be used for more than 2 terms at a time. Questions there? Why don't you guys see if you can do this derivative? If we look, we have 2 things being multiplied together, but they both have a t in them, so we have to do the product rule. So product rule, derivative of the first. So derivative of 2 is just 0 minus 3 times the derivative of cosine. What is the derivative of cosine? So we have 0 minus 3 times negative sine. So it just becomes a 3 sine t. You guys see where I got that?
Why is it negative?
Okay.
Oh,
So
minus
0
3.
minus 3 times negative sine t, which would simplify into a positive 3 sine t. So derivative of the first times the second plus the first times derivative of the second. Derivative of e to the t is still e to the t. And there's not much you can do here. You can distribute if you would like. So we get to there. Is that okay? Let's try one more for today. And if on this problem, if you had factored out, I noticed on the quiz, a couple of you do pull out your grades common factors sometimes, and that's fine if you did. Different ways to write our answer for sure. All right, this one. I want the equation of the line tangent to the curve y equals cosine squared x at the point P on the graph where x is pi over 4. All right, equation of a tangent line. What do I need to write the equation of a line? Yep, we need a point and we need a slope. So to get my slope, we have to do the derivative. Can I do the derivative of cosine squared? Not when it's written like that. I can do the derivative of x squared. But if I want to do cosine squared, I have to write it as cosine times cosine. So slope of the tangent line, we have the derivative. So derivative of the first, derivative of cosine is negative sine, times the second, plus the first, so cosine, derivative of the second. Derivative of cosine is negative sine. What do you notice about these?
The same.
They're the same. Negative sine x cosine x plus negative sine x cosine x is negative 2 sine x cosine x. Alright, so to get my actual slope, we have to plug in the x. Pi over 4, that's the same as 45 degrees. Sine of 45 degrees?
Radical 2 over 2.
Cosine of 45?
Radical 2 over 2.
Okay. So I get negative 2 times the square root of 4 over 4. Square root of 4 is 2, so we get negative 4 over 4, so my slope is negative 1. I need my point. I know my x, so y is the cosine of x squared. So cosine of pi over 4 is radical 2 over 2 squared is 2 over 4 or 1/2. So if we plug into y equals mx plus b, y is 1/2, m is negative 1, x is pi over 4 plus b. So I get 1/2 plus pi over 4 for my y-intercept. Not just a single number, but unless I'm picking up a calculator, I'm not going to be able to actually combine those. So we'll leave it like that. So the equation y equals m, which is negative 1, so negative 1x or just negative x, plus b, which is 1/2 plus pi over 4. And we have the equation of our tangent line. Questions for me?
Where'd you get the 1/2 for y?
So I plugged pi over 4 into my original equation.
Oh.
Other questions? So on this, so here is your assignment. If you get done with that and have extra time, you can start the day too, because I'm a little